All right, so we are on day 2 of correlation coefficients. And learning goals for this one, I can calculate the linear regression and correlation coefficient using technology. And I can determine whether a correlation is weak, moderate, or strong based on the correlation coefficient and explain my reasoning. All right, so we've gone over these before. So as far as, what strong positive is, they're hugging the line pretty closely. Weak positive, notice they're way out here. So this is kind of the best way to tell. Like if you can draw, lines around the dots and you can see like how close they are, that'll give you an idea. Like strong negative, if we, get right in close, we can kind of see how all the lines are. Weak negative, they're out further. Moderate, that's kind of the new one. Notice that's a little bit more in between. So it's not quite as far out as weak, but not quite as close as strong. So we're adding one more in there as a possibility. We still have no correlation. All right, so that's the new one. All right, so as far as correlation coefficient, so we've kind of like gone through before, what the strength means, but again, now we're adding in moderate. So like strong, I would say, would be somewhere around like, if it was on the negative end, like a, let's say a 0.75 or negative 0.75, to, negative 0.8. That should actually be the other way around, but that's okay. Whereas this would be a positive 0.75 to positive 0.8, this point right here. Okay, and then like, I don't know, positive or negative 0.3, positive 0.3. You get the idea as far as like where it goes. So moderate's going to be kind of in there. All right, so let's look at some of these examples. So scientists are trying to determine if there's a relationship between the amount of cricket chirps per minute and the temperature of the air. And we need to use the data below to compute the correlation coefficient of the data. So we're just finding the correlation coefficient. We're going to use that to answer the question. So again, all you're going to be doing is, opening a new document in TI Nspire, putting in this data right here. So all this, the temperature, the chirps, and then when you're done, hit menu 431, and that's when you'll have that column on the right, the linear regression column that shows you like M and B, and then there's an R squared, but we're looking for just R, so not R squared, so no R squared, we want R. And if you put that in, you'll see the correlation coefficient is 0.99849. So we're going to use that to determine is the relationship between the temperature and chirps per minute strong, moderate, or weak. And because it's so close to 1, we would say that the relationship between temperature and chirps per minute is strong. All right. Next example, same type of problem. So this time we have hours in the mall. So again, these are your X values, these are your Y values. And so when you put this in Nspire, like maybe you label that first column hours and the second column dollars, that's fine. Whatever you want to label it so that you know the difference is fine. But just make sure when you do this menu 431 that when it asks you at that point which one is your X, that you're using this information, and which one is your Y, that you're using the second row there. All right, so when you do this, you get a correlation coefficient of 0.068881, which is pretty darn close to just 0, but not quite there. So because it is so low, we would say that since the correlation coefficient is close to 0, there is a weak correlation between the amount of hours spent in a mall and the money spent. All right, and that is it for target 8C. By now, you should be starting to get comfortable using that calculator on your laptops, devices, or whatever. But if you still have questions or you're still running into issues, please let me know and we will get them straightened out. Take